that you should become the entrepreneur. And if you want to become the successful entrepreneur, handling of the equipment, the unit operations, so that you can design the new process lines, you can develop new products, the basic fundamentals of food engineering is must. That's why we know Dr. Samuel, he makes the very complex subjects in a very simple one. So I have requested Dr. Samuel to give about the unit operations involved in the food processing engineering. He will be dealing these aspects in detail. Dr. Samuel, please.
Yeah. Thank you, Dr. Saluja. I'm thankful to your department for granting me this opportunity to come on air to tell the students about the food processing and engineering aspects. Today, as I told you, the food processing scenario in our country, in fact, is not as much as in the world over. If you find that mostly in other countries, if you go to US, you go to Malaysia and other countries, the processing of food is of the tune of about 50 to 70%. Whereas in our country, the processing of food is just about 2%. And obviously, the processing aspect have to be given more importance in the coming days, and we would like to give food processing a very major boost in the coming years. Now, I would like to deal straight away with the subject of food processing and engineering. First thing is that I would like to talk is food processing and engineering part 2. In any kind of food processing, there are different unit operations involved. The unit operations which are most important are size reduction, milling, material handling, and transportation and packaging. I'll get down straight away to the first and very important unit operation in food engineering, that is size reduction. The term size reduction is applied to all the ways in which particles of solids are cut or broken into smaller pieces. An ideal size reducer should fulfill the following conditions, that is, it should have a large capacity, it should yield a pre-desired size product or range of size, it should have small power requirement per unit of product handled, and it should be easy and trouble-free as far as its operation is concerned. Now, there are various methods of size reduction. I have put them into 4 categories. First is crushing, the second is impact, the third is shearing, and fourth one is cutting. There are principles of size reduction machines. Now you see, all these size reduction unit operations, they can be carried out on different machines. The first machine is subgrouped as crushers, the second we call grinders, the third as ultra fine grinders, and then we have got cutting machines. I will be dealing one by one with each and every aspect of these 4 types of principles of size reduction machines. Now in front of you, the crushers are displayed. If you can see on top, the jaw crusher is given. Now jaw crusher, if you look here, if you look at the jaw crusher, if you look at the jaw crusher, there is a fixed jaw on the left hand side here, which is stationary and it does not move. The other one is a moving jaw, which is known as swinging jaw. This is the area where the material which size has to be reduced is introduced, and with the help of a mechanism here and a 5-wheel and eccentric, the material is pounded time and again, and it is discharged at the lower end here, which you see here. Now here, this jaw which you see here, it opens 250 to 400 times per minute in order to give a proper size of the product that you need. Also, the capacity of these kind of materials or equipment is up to 1200 tons per hour, and it can reduce a size of 250 millimeter to up to 6 millimeter. Then we have got the gyratory crusher. If you see here, gyratory crusher is nothing but it's a vertical model of jaw crusher, which you see here. Here again you see the feed is put into this area, and feed is put into this area, this annular space, and the material comes in this area. And if you see here, these are the crushing heads, this one and this one. These are the cutting heads, and at a high speed these crushing heads, they revolve, and the material which is received in this feed area, this is crushed. Now the speed of these gyrations is about 125 to 425 gyrations per minute, and maximum capacity of such machines is 400 tons per hour. Similarly, if you see here, there are smooth roll crushers. Smooth roll crushers, they accept feed of different sizes, but normally it is used as a secondary crusher, because most of the big crushing is done in bigger crushers, and then that feed is taken and put into the smooth roll crusher for further crushing. And here in a smooth roll crusher also you see the roll diameter. The diameter of the roll is somewhere around 600 millimeter to 2000 millimeter, and the face is about 300 millimeter to 914 millimeter, and speed is about 50 to 300 rpm for these rolls when they crush the material. And material is normally reduced from a higher size to a relatively smaller size, and then further a smaller size is done. If you see the discharge, and here again this is motor operated, and if you see the feed comes from the top, and a flywheel is used to store the energy here for this metal. Now, limiting size of particle which can be handled by smooth roll crushers. Smooth roll crushers are secondary crushers, as I told you, with feeds 12 to 75 millimeter in size, and products 12 millimeter to about 1 millimeter can be handled. The limiting size dp max of the particles that can be nipped by the rolls depends on the coefficient of friction between the particle and the roll surface, but in most cases it can be estimated from the simple relation dp max is equal to 0.04 r plus d, where r is the roll radius and d is the half the width of the gap between the rolls. Now coming next to the grinders, we have got several type of grinders. On the left you see this is hammer mill. Now hammer mill, if you see here, hammer mill is a grinder which is used for grinding small sizes here, and hammer mill has two types of equipment in this. First thing, if you see the hammers, see the 1, 2, 3, 4 hammers are shown here. These can be more than 3, 4, it can be 6 or it can be 8 also. There are two types. One is a fixed hammer type where the hammer is fixed. In the second type, swinging hammer type, where the hammer swings on its axis. So both the types are used for fine grinding of goods like masala, that is spices you can grind, such as chilies, you can grind turmeric, you can grind jeera, pepper, or anything to very fine size you can make it, and the sizes are 1 to 20 mu m that can be done. Similarly, if you see the attrition mill here, now you see the attrition mill is nothing but something like our atta chakki, something like our atta chakki. It has got one fixed stone and another with a moving stone. Material, you see the feed is introduced at the center here into the masala, into the chakki, and it is in the center, and it goes into the between the moving stone and the stationary stone, and there it is ground in between the two. The discs are moving at a speed of 250 to up to 1400 rpm, and the disc size is about 1400 millimeter, and wheat, gram and other grains can be ground here to a mesh size of about 200 millimeter. The attrition mill has several other uses which it can be put to. Then we have got next is ultra fine grinders. If you hear the ultra fine grinding, wherever it is needed, it is done. Normally it is liquid grinding, where syrups, milk and puris, they can be ground to a finer size here. Here again, if you see, the rotor speed here is 50 meters per second, and capacity usually of these ultra fine grinders is less. It is 2 to 3 liter per minute. However, bigger mills can have up to 440 liters per minute of capacity in these ultrafine grinders. Then you come to the next, that is cutting machines. Now cutting machines are used for cutting different food materials into small pieces. They have got, if you see here, they have got rotor and they have got flying knives. And this here, the flying knives, when the rotor rotates at a high speed, the knives open up and they fly, and they are used for cutting the material. The rotor speed here is somewhere around 200 to 900 RPM, and you can have as much as from 2 to 12 flying knives, which will be used for cutting the food material. And you may also have the stationary knives. If you see here, these are stationary knives, and these are also used for helping in the cutting. Now here, like for example, you can cut the material into cubes, squares, or even diamond shaped material, say about 5 millimeter in size. For example, if you are going to have some material like carrots, you want to have radish or such kind of material, or even turnip ground, and you want them to be reduced to a size of about 5 millimeter and formed into cubes, thin squares, or diamonds, this particular machine, cutting machines, can be used for that purpose. Now another very important aspect in such kind of equipment is energy requirement for size reduction. Obviously any machine can be designed and developed, but one important aspect remains how much energy it requires to operate. And the energy requirement for size reduction can be calculated with this formula, which is in front of you. That is P is equal to WF is equal to FE suffix S AWB minus AWA divided by NC and NM, where P is the power requirement, W is the energy input, F is the feed rate, ES is the surface energy per unit area, AWB is the area per unit mass of the feed, and AWA is the area per unit mass of product. NC is the crushing efficiency and NM is the mechanical efficiency. Here I would like to point out that AWB is the area per unit mass of feed. It is certainly, the feed is bigger and more in size, whereas AWA is the area per unit mass of product, which is certainly smaller. Now in order to do the grinding or do the energy requirement, there is one term called fineness modulus which comes into action and play. Fineness modulus indicates the uniformity of grind in resultant product. It is determined by adding the weight fractions retained above each sieve and dividing them the sum by 100. Why fineness modulus is important? The reason being that anything which you are going to pound and you reduce its size to a very small and fine size, obviously you would like to know the uniformity of size in that mass. And it is very important for anything like, for example, the functional properties of wheat flour. Functional properties are good if you find that the size is uniform. So in order to know whether the size of the flour is uniform, then it is very important to know the fineness modulus. Now you see here the whole ground material is taken on a BIS sieve number 100, and then they are arranged from 100, 70, 50, 40, 30, 20, and in a descending order. And the material is, the whole lump material is kept on the top sieve, and with the help of a sieve shaker, the sieve is, whole set is shaken for 5 minutes. After 5 minutes, you take out all the 7 sieves, that is 100, 70, 50, 40, 30, 20 and 15 and pan, and then you weigh that what is the weight fraction which is retained on each sieve. Now when the weight fraction is weighed, then you calculate what is the percentage material retained on each sieve, and with that help then you calculate the fineness modulus. Now you see here, as total percentage material retained and total, we find here that we have 279, and 279.72 divided by 100 is equal to 2.7972. And this shows us the fineness modulus shows us the uniformity of the product over the entire range. And even in that mass for wheat or whatever you have ground, if you want to know what is the average particle size, that can be given by the equation D is equal to 0.135 in bracket 1.366 to the power Fm, the fineness modulus which you have just calculated, and this will give you the average particle size. Then coming to the next topic in the same subsection, that is milling. Milling is a general trade name which normally means reduction of food grain into various end products like meal, flour, splitted products, etc. Milling includes cleaning, grading, separating, mixing, purling, polishing, dehusking, size reduction, etc. The meaning of the term milling varies with the crop. For example, milling of wheat refers to a grinding operation to produce flour, whereas in rice industry, milling refers to overall operations in a rice mill, i.e. cleaning, dehusking, paddy separation, bran removal and grading of milled rice. Milling also refers to extraction of juice, oil or separation of fiber. Now coming to the milling equipment, first we will take up milling equipment for solid foods. If you see in solid foods something like fruits and vegetables, you need to reduce their sizes, and here again the size reduction of fibrous foods is going to be detailed. Now if you see here, the first picture is slicing equipment. Now here the material is kept on the top, and a rotor with blades is rotated at a reasonable speed, thereby slicing the product to a predetermined size. You can see here there is a small blades which are protruding out of the rotor, and the product can be pressed against this rotor and give you a desired and predetermined size. Similarly, dicing equipment is also given on the right hand side, that is B. Here also you find you can dice the product into different sizes of rectangle or even cubes. And in dicing equipment also what is done here, if you see, the material is first cut into longitudinal direction, and then the second knife or rotor will cut it into horizontal direction, vertical direction, so thereby giving you a small diced product as you see on the right hand side here. Now these products, dicing products and these products, they are very much used in food industry, especially for canning of this material like carrots and other material. Dicing also is utilized in food industries where you are making food products on a large scale. Like for example, if there is a samosa making factory, or if there is a factory which produces potato fingers. So for potato fingers you have to cut the potato into predetermined size, and then it has to be fried and produced. So slicing and dicing equipments, they are used in food processing industries even these days also. Then coming to the size reduction of dry foods. Now in dry foods we have got size reduction equipment like ball mills, disc mills, hammer mills and roller mills. On the left side, if you see, the hammer mill is here. It is used for dry fruit size reduction here, and which I have already explained to you earlier. Now if you come to the conical ball mill on the right hand side, in this mill you see there are different steel balls, and these steel balls are of different sizes. They vary from mill to mill, but their sizes are different. And material feed inlet, it is introduced from here at this point, and then it goes inside the mill, and as it goes inside the mill there are large size balls on the center here and the small size balls on the right hand corner here. Now material gets crushed by ball here, and ultimately it goes into a fine material and it comes out from this point. Now the whole machine is driven with the help of a motor and a drive gear which is attached to this motor, this particular equipment, and There are larger balls also and smaller balls also which do the operation. Now coming to the method of separation. What is separation? The unit operation of separating can involve separating a solid from a solid, as in the peeling of potatoes or the shelling of nuts. Separating a solid from a liquid, as in the many types of filtrations, or a liquid from a solid, as in pressing juice from a fruit. It might involve the separation of a liquid from a liquid, as in centrifuging oil from water, or removing a gas from a solid or a liquid, as in vacuum removal of air from canned food in vacuum canning. Now coming to the color separation becomes very important in food industry, where you have to separate the off color product or undesired color product from the desired color product. For example, if you take the rice milling industry, in rice milling industries our companies are exporting rice to outside country, especially the basmati being a very special kind of variety of rice. We are in export business and we have got several mills all over India and especially outside Delhi city. Now there the problem is that many of the rice kernels, they change into color. Instead of white, they are amber in color. So that is a problem. They have to be removed and only white kernel has to go. In that case, the color separator can be used. The other kind of thing could be that if you want to remove from kacha fruits and pakka fruits, if you want to differentiate, like for example, if you want to differentiate green color apples from the red color apples, again the color separators can be used. So color separator can be used in any industry, and I will just like to tell you about this. You see here, this is the hopper where the material is received, and then the material passes. Let us, for example, it is mixed rice, colored rice as well as white rice. So we have to remove the colored rice from the white rice. Now how the rice travels here on this conveyor, and this conveyor then throws it into a viewing chamber here. This is known as viewing chamber, and you will find here that there are cells, photo cells. The two photo cells are here. And what do they do, these photo cells? That as the rice falls into that, they judge the light which is reflected from these. Now for example, if it is a white colored rice, the light reflected will be more, whereas a colored rice will absorb some light and reflect only little rice. So these photo cells will be able to sense the light which is reflected from a particular rice kernel. They will send it to their machine here, which will sense the light, and accordingly it will give a sensor here. And see, there is a sensor here, and immediately this sensor will allow it to deflect the path of the undesired rice to the other side. And see here that and see here that here, if you see in number 8 here, the undesired material will come here and desired material will be collected here. Also, some of the newer machines are using air jet arrangement, and in air jet arrangement, what are they doing? That the signal is conveyed to the air jet, and immediately for a very fraction of a second the air jet is released, and immediately the rice path is deflected and it falls into a separate area. Then size based mango separation. If you see here, this is a mango, and how to separate mangoes on the basis of their size. And you find here that we have got a mango grading machine which has channels and increase based on the increasing size. Now as mango comes on the first phase here, the size is smaller. So if the mango is smaller, it will drop here. Then the second bigger size will drop at the second point, and the larger size will drop here. So this can also be used for as a grading device or separating device for fresh fruits and vegetables. Then coming to the optical grading machines or optical separating machines. If you see here, this is an optical separating machine. there is a belt which is going all around, and you find here that this is specifically meant for apple, separating the apples. One is diseased apple from the fresh apple. Now fresh apple does not have any outside color change, whereas a diseased apple or a mechanically damaged apple will have a different black color spot on outside. Now with this help of this optical grading or optical separating machines, we can separate the diseased apple from the fresh apple. And here you find on this particular rotor, it is rotating, and as a particular optical machine, it finds out where the problem is, and if the product is not acceptable, it will drop it immediately. A gate will open and it will drop. Otherwise the product will be conveyed and it will go to the second outlet. Then there is a lye peeling. Lye peeling is again practiced in many cases where you want to, supposing you want to take out the potato skin from the potato or any other material. A lye peeling is a device which is used, and see here the lye peeler. It has got caustic in the bottom here, the caustic solution, and you put the material here from the food chute, and the material will go along with the wheel. If you see here, it will be dipped in the lye. Lye is nothing but caustic. The skin will be separated, and after the skin is separated, the treated produce will be sent from here to the washer line for separation. Now coming to the material handling. Material handling is again a very important aspect in food processing. Now there are different kind of conveyors or material handling equipment which are used in food industry. I will just list them out for you. That is belt conveyor, roller conveyor, chain conveyors, screw conveyors, vibri conveyors, and flight conveyors. You can see on your monitor there are certain pictures also given for belt conveyors, roller conveyors, vibri conveyors, and other kind of conveyors. Now coming to the belt conveyor. Belt conveyor can be used over a large length where you have to transport material over maybe even 1 mile long or 2 mile long. You can do that, whereas other types of conveyor, they have got their limitations. Now if you see here in this figure diagram, and where the arrow is pointing out, you see here this is the belt which has been put at an angle, and you see there are idlers here on the right and left. In order to increase the capacity of transportation on the belt conveyor, you can change the angle. See here, angle 30 degrees or angle 45 degrees, depending on your requirement you can say. Now these idlers, they are not powered, only the bottom portion is powered for the motor, from the motor, and the material is conveyed on the belt conveyor from one point to the other. The capacity of the belt conveyor can be calculated with the formula area of cross section in meter square into belt speed in meters per minute into 60. This is the capacity in meter cube per hour. And then if you want to know the horsepower requirement, it is equal to the capacity as you have calculated earlier and multiplied by 0.48 plus 0.101 L divided by 100, where L is the length of the belt. Belt conveyors can be used to transport material, granular material, powdery material, and different type of materials from one end to the other. Normally belt conveyors are not used to transport fruits and vegetables, but in certain situations they can be used for that. The advantage with the belt conveyors are that they can be used for conveying material over a large length, 1 kilometer to 2 kilometer, and also that they can be used in open. However, they have a limitation here that the power requirement with belt conveyor is much more than the power requirement of other kind of conveyor machine. Now coming to the screw conveyor, if you see here, this is nothing but a screw conveyor. A screw conveyor comprises of a central central shaft, and on this shaft the flights are arranged. if you see here, the flights are arranged. Then all this assembly is housed in a trough, and then it has got a feed chute here and a discharge one. And if you see here, this is the main shaft, and the flights are arranged over it. Distance between the two flights is known as pitch, and total length is known as L, whereas the diameter is known as diameter of the flight, which is given here. The capacity of screw conveyors can be calculated in meter cube per hour, that is 47.2 in brackets d square minus small d square into P into N, where capital D is the screw diameter in meters, small d is the shaft diameter in meters, P is the pitch in meters, and N is the revolution per minute of the main shaft. The horsepower requirement can be calculated with the formula QLWF divided by 4500, where Q is equal to conveyor capacity in meter cube per minute, L is the conveyor length in meters, W is the bulk material weight, that is kg per meter cube, and F is the material factor, and for paddy it is 0.4. Here I would like to just add that screw conveyors, they have a distance limitation. They cannot be used for conveying materials for a long length. Very short lengths, somewhere say around, they can start from 1 meter and go up to say about 20 or 25 meters. However, they are very efficient in conveying materials like grains, paddy, bran, rice bran, and powdery materials. Then we come to elevators. Now there are different type of elevators, that is bucket elevators, pneumatic elevators, flight elevators, and magnetic elevators. We will deal here with the bucket elevator first. Now if you see, what is a bucket elevator? A bucket elevator is an elevator which has got number of buckets which are arranged on an endless belt which is mounted on two pulleys in this particular configuration. As the pulleys operate, the belt is normally made of rubber or it is made of canvas, and as the belt operates, the buckets also go along with it, and they pick up the feed from here, from dump where the material is dumped, granular material, normally grains, and then they pick it up and they can discharge it at this end here. Now here if you see, the elevator capacity in meter cube per hour can be calculated as bucket capacity in meter cube into number of buckets per meter length of the belt into belt speed in meters per minute into 60. As you see on your monitors, the capacity can also be calculated in tons per hour as capacity meter cube per hour into material density. Material density means bulk density. For paddy it can be taken about say 600 kg per meter cube, and for other materials the density varies, divided by 1000. Horsepower required to operate the bucket elevator can be calculated as QHF divided by 4500, where Q is the capacity of the bucket elevator in kg per minute, H is the lift of elevator in meters, and F is the factor. That factor varies from 1.2 to 1.5 depending on which side you are loading material. Now there are certain operational things which have to be kept in mind while operating a bucket elevator in a grain industry or a food industry. Here you see the picture given on the top. If you have to maintain a particular speed for the bucket elevator, if the speed is too slow, see what happens. If the speed is too slow, what happens? That cups spill the grain into the up leg and down leg. Breakage occurs when the kernels strike the cup ahead, when tumbled within the pulley, and when re-elevated. As you find here that at a slow speed it will fall down here, and there will be breakage also of grains. And if you are operating your machinery at a too fast pace, of the speed is too much, then what happens here? Cups lose all holding and discharge control. See here, and material goes helter-skelter all through, and then again here you find excessive breakage and undue head wear of the head inner. But if the recommended speed is used for this, you will find cups fill and carry perfectly, then discharge directly into the throat, no spillage, no breakage. So this should be kept in mind, that we must operate our bucket elevators at a optimum speed while handling the granular material. Now coming to the selection of material handling devices, there are certain points that I would like to highlight. For any food industry, whether it is grains or whether it is fruits, you need to keep in mind certain points before selecting a conveying or material handling device. The conveying device has to be selected according to the characteristics of the product being conveyed. Characteristics here mean whether it is a powdery material or it is a material which has friction or any other kind of material. The stability of the conveyor must be ensured under all normal working and climatic conditions. The capacity of conveying and speed rating should be maintained at specified limits. The dead load of the conveyor should be low in relation to the weight of transported product. In a conveying system, possibility of use of gravity should be taken into consideration. The capacity of handling conveying equipment should match with the capacity of processing unit or units. Spillage of conveyed products should be avoided. Pollution of environment due to noise or dust by the conveying system should also be avoided. Now coming to transportation and packaging. Now once the produce has been processed, it has to be neatly packaged and then transported. Now let us look what essentially the packaging is. Packaging aims to provide protection from all types of external damaging effects. It is an integral part of food processing chain and helps both producers and consumers to transport, store, sell, purchase and use foods more efficiently. It is a means of ensuring that the product is delivered to the user in known quantities and in the expected condition for a specified shelf life. It is a means of making the food more attractive in order to promote its use and increase sales. It conveys information to customers about the type of food they are buying, how to prepare it, its shelf life, and that it conforms to the relevant food legislation. Now just this chart or this flow chart is giving you a distribution system for a consumer goods. First, when the material is produced, then it is packed and sent to the factory go down. Then it goes to the sales go down. Then it goes to the distribution go down. Then retailers storage, retail store, consumer shelf, and then recycling and other uses and reuse. So this is the flow chart which shows you the product and its movement up to the time when it goes to the consumer and beyond it. Now you see these are some of the food packages which show you how beautifully, see, a food package should have a very attractive get-up, so that a person who wants to buy the material is immediately attracted to it. You see the material can be stored in glass bottles, packaged in CFB boxes and Tetra Pak, wooden boxes, paper and plastics. And if you see, all the information regarding the food should be displayed or printed on the package so that the consumer can immediately know what the package contains. Now, what are the different modes of transport? Like bullock and horse-drawn cart is one way of transporting material. Then road trucks, rail goods trains, ship and cargo. There are several methods of transport which are used in our country, and role of packaging of agricultural and food materials can be described with the following words. We have to have two kind of considerations. First is the general considerations for a packaging material, that it should be able to absorb mechanical forces, like for example impact, vibration, compression or abrasion. It should be able to take care of climatic influences that cause physical or chemical changes like UV light, moisture, oxygen, temperature changes, contamination by microorganisms, insects or solids, and pilferage, tampering or adulteration. A package should be pilfer proof. so that nobody can take out anything. Requirement of packaging material with respect to marketing considerations, the brand image and style of presentation required for the food, flexibility to change the size and design of the containers, and compatibility with the method of handling, distribution, and the requirement of retailers. Now, from the package, certain things are expected. What are the functions of a package? The function of a package is preserving against spoilage of color, flavor, odor, texture, and other food qualities, preventing contamination by biological, chemical, or physical hazards, controlling absorption and losses of O2 and water vapor, facilitating ease of using product contents such as packaging that incorporates the components of a metal together with meal kits, offering adequate storage before use such as stockable, resellable, pourable, preventing or indicating tampering with contents by tamper evident labels, communicating information regarding ingredients, nutrition, facts, manufacturer's name and address, weight, barcode information, and so forth via pack age labeling. Marketing standards of packaging, including worldwide acceptability of certain colors and pictures, symbols vary and should be known by the processor. Package also should carry such information as merchandising messages, health messages, recipes, and coupons. Now, packaging materials are metal, steel, aluminum, glass, paper, and plastics. And these, before when they go into packaging, there are certain tests which have been performed on the packages, that is thickness, the basis weight, tensile strength, bursting strength, water vapor transmission rate, gas transmission rate, tearing resistance for paper, impact test for plastic, abrasion resistance, heat seal strength, environmental stress cracking. And some special packaging materials are nowadays being used than the normal ones, that is edible films, foils, laminates, vacuum packaging, modified atmospheric packaging and gas fishing packaging, control atmosphere packaging, active packaging, aseptic packaging, and flexible packaging. Nowadays, if you find the glass first packages are very much in use where potato chips are sold. And you see here, this is a controlled atmospheric package which is shown here. You will find on the left side, the material which is stored is in the ordinary air, whereas on the right hand side we find that it contains a combination of oxygen and CO2 which is monitored, and you find that product after 3.5 months of storage is now very nicely kept. This is a controlled atmospheric storage which our division has developed, and we have sent it for patent also. And these are some various household packaging types for foods, and see, it is very attractive, and all the information which is needed by the customer is displayed or it is printed on the material. So a packaging material for the food should be very catchy. It should be the packaging which should attract a person. And then you see here some of the packages which are shown here. These are shown for packaging of potato, then some vegetables like capsicum, and some of these on the top right hand corner you will find the onion packaging. It is done in net bags, and we see on the left hand side also some of the packaging materials. Thank you very much. Thank you for giving me this time. And in nutshell, I would like to say that all these 4 aspects which we have considered today, these are some of the very important things which should be kept in mind in a food processing industry. Thanking you.
Thank you, Dr. Samuel, for very I must say very good coverage of the very complex subject in a very simple way. Thank you very much.
Thanks.